So when we're looking at the stepper motor and controlling it, really it all kind of happens in the code. We looked at the video, the hardware video, and there wasn't too much setup. So really where all the control is happening is within the code, right? So let's start with our declarations first. Okay, so we know we've 4 inputs and they're just digital inputs. Okay, so I went in on pins 16, 17, 18 and 19. That was my input 1, input 2, input 3 and input 4. Okay, so what I did, I could have listed them all out as digital output pins I'm going to use, but what we're doing is we're just grouping them together using the bus out command. So I can just group them all as this is my motor, all these pins are to do with my motor, so we've used this bus out command before, and then what I can do is I can just do one command that will turn on whichever pins I want to turn on in that instant. Okay, don't worry too much about this other stuff, these declarations aren't too important. And then this is just some of my initializations, starting with some integer variables, and I'm starting them low. We'll come back to them in a minute, right? The main thing I just want to look at for the start is our switch case. Okay, so this bit here in the orange, don't worry about anything else for the moment, right? So what I said was I want to trigger each of these pins individually. Okay, and what that does is the LED, remember the LEDs you've seen in the hardware video, they will light up each step. So what you got to do for your step and motor to work is you've got to trigger this this part of the coil first, then this part of the coil, then this part, and then this part, and then you go back to the start and you just keep looping around them sequentially, okay, one at a time, and that lets you go through the steps one at a time in that order. Okay, so keeping that in mind, what we just do is we if we just look at how we're calling the motor, so what we're doing is we're using the hexadecimal representation to do the bus out command. Remember, when we're grouping these together, we can do a nice hexadecimal that will trigger it. So remember, I have four pins there that I'm not going to turn on. By using the hexadecimal value of 1, what that will do is it'll set one pin high and all the rest to 0. Now the other tricky bit with the bus out command is, remember, you have to read it back in then reverse order. So what that will actually do is it'll set pin 16 to 1, and then those will be a 0. And then what we do is we put the hexadecimal value 2 in, because all that'll do is just, again, it'll just highlight one of those on, and then keep going, put the hexadecimal 4 value in, and then 8. So do you see that? Do you see the way there's just one output pin on at each time? So what you're doing is you're looping through that, just triggering those, so that'll increment through the steps in the motor for the stepper motor. Now I have a default condition here, which is just that if we did get a value different than 0, 1, 2 or 3 here for a case, this is just the default case to put everything to 0. Okay, so that's what we're trying to do. We're trying to trigger each pin individually and then successfully go through that kind of loop where this one goes on, then this one, then this one, then this one. Okay, so if we look at that again, remember, this is what we're changing. This is the step. Okay, so the step starts at 0, then it comes out, we increment it, and it goes back in, goes to 1, does this line of code, then we increment it again. So the step is now at 2, so it comes to this line of code, then we increment it, steps now at 3, goes to this line of code, and then when we increment it, this comes in. Look, if step is greater than 3, go back to 0. So it was greater than 3, so it goes back to 0, and then we loop back in. So we're back, step is 0, we do this line, increment it up, do this line, increment it up, do this line, increment it up, do this line, increment it up. Oh, we're greater than 3, go back to 0, and then come round. So that's all we're doing there with that switch and case values, that we're just doing it incrementing through the steps, these kind of 4 scenarios that we want, and we're just incrementing through them nicely, and we're just keeping looping that round. So we could either go in the forward direction, or if we wanted to go in the reverse direction, we could decrement it down. So again, we could start at 3 and work our way down, and we would turn the motor in the reverse direction. Again, once we just trigger it in the scenario, this pin is on, then this pin is on, then this pin is on, then this pin is on. And again, if you're looking at it going in reduction of order, when you get to 0, okay, it'll go to -0, but then we're saying, so when that goes less than 0, start at 3 again. So start at 3 and then work your way back down in reverse order. Okay, so that's all that's happening within here. A couple of little if statements and whether we want to go forward or reverse. Okay, so this is just using a different variable that if we want to go forward or reverse, so you don't need to worry about that too much. But if you just get that basic idea in your head that all you got to do is just trigger one of those input or those output pins that's going into our motor at a time, sequentially, and it's only just those 4 that you need to loop through. Okay, so that will start getting your motor to turn. Now, the wait command is just the speed between each of those steps. So we have a very, very small wait time, which allows us to speed nice and quickly, as quick as possible, through the motor turning. You see in the hardware video, when I slowed that down, you could actually see each LED lighten up as it was triggering the motor. But then when we speed it up very quick, you don't actually see that. It just goes through this very, very quick. Now this switch case, this loop, is still embedded within another loop. It's embedded within this while loop here. Okay, and what we're doing is, you can see there's the 2048, the total number of steps to get 360 degrees. So again, we're just using I, that'll just run through this and do it. Ultimately, it will do it 2048 times. So whatever amount that this goes into that 2048 times, it will just trigger through that cycle that amount of times, because there's that many steps. So remember, this is 1 step, this is 2 steps, 3, and then 4 steps, and it keeps going through that up until it gets to 2048, and that will be our full 360 degrees. If you only wanted to turn it 180 degrees, you would just reduce the steps by half. Okay, so that's it's a wee bit kind of complicated, because we've a loop of just looping through our steps, but then we have the loop that's going through how much we actually want it to turn. Okay, and then we're just doing some checks to either if we want to go forward or go back, and then we're just making sure we stay within that range, because that's the only way we want to trigger it, but we just want to keep doing that in a loop. Okay, so everything else shouldn't be too bad. There's just some include our usual mbed.h. There's no special library for the stepper motor. I'm using the bus out command. Okay, if you wanted to put some LEDs to show the direction or some button inputs, they'll be for a different question really. Just initializing the variables that we're using. So our I for the long loop here, our step variable to get us through the step loop, and yeah, and that's it. So hopefully this makes sense. Again, if you want to change the amount of rotation, you're just changing the number of steps, but the important thing is to have that sequentially going. So this is in full step operation, in the sense that we're going through the full 2048 steps. There is, as I said, more efficient ways of doing this, to go through a 4-bit step or an 8-bit step, but where you do a different combination within here. But for the moment, we're just trying to keep it a little bit simple.